Let's get started on part 2 of lab 1. So in this lab, we're going to be plotting on a very different sort of map projection. And we saw this in the lecture, but this is an equidirectional map projection centered on the North Pole. So everything on this map, all of the lines that you're seeing radiating out from the center are lines of longitude, and all of the closed circles are lines of latitude. So the first thing it asks you to do is to label a couple of things, the North Pole and the prime meridian. We just mentioned one of those. Let's get that on there. I'm just going to put on NP for North Pole. And of course, that's going to be right in the middle. And then the prime meridian. Put that on as PM. And of course, the prime meridian is the line that runs right through Greenwich, England, which is right there. And it's this line that would be vertical on the piece of paper and running right down through there. So we've already labeled the prime meridian. And if we wanted to, we could also put the value of longitude there. And the value of longitude on the prime meridian, as we know, is 0. All right, great. So the next thing it asks us to do is to label every 90 degrees of longitude. So we already have the 0 one on there. That's a good start. I'm going to put on the one over here, this horizontal line here, and that's going to be 90 degrees. And if we want to verify that, we can count them: 15, 30, 45, 60, 75, 90 degrees. And since that's east of the prime meridian, it's 90 degrees east. That's also positive 90 degrees. And over on the other side, cutting through the United States, that would be 90 degrees, but in this case, it would be 90 degrees west. And of course, right at the top here, that's where we're going to put 180 degrees. And you could put east, west, or neither, or both. That's because if you're going around this way or going around that way, you're going to hit 180 at the same spot there. All right, so good labeling there. The next thing we're going to do is draw on a curve on the map to show which direction the Earth is rotating. So it's kind of hard to draw this one. I just kind of use this, but the Earth is rotating around the North Pole. We know that. And so you either just draw, depending on how you think it's rotating, just kind of draw an arrow that looks like that. Or if you think it's rotating in the other direction, you can draw on an arrow that looks like that. But please get that arrow on there, okay? And then the other thing you're going to do is you're going to plot some points. So one of these points is Fossil, Oregon. And it's at a latitude of 45 degrees and a longitude of 120 degrees west. So let's add a point for that. So first I'm going to put a point on my map as a circle. And so Fossil is 45 degrees north, so 15, 30, 45. It's along this line here. And it's 120 degrees to the west. So 90, 105, 120. So 45 and 120 is going to be right where those two lines cross there. Okay, so that's approximately where Fossil, Oregon is. And let's put on one other point here. Let's put on New Orleans, Louisiana. That's 30 degrees north and 90 degrees to the west. So New Orleans is 30 degrees north, so 1530 is going to be along this line here, and then it's going to be 90 degrees west. It's going to be right where those two intersect. So I'm going to add a point there as well. And you'll add all the similar points in the same way. Once you've added all those points, you're going to tell for all those points what the approximate time difference is between Fossil, Oregon and these 4 other places here. And the way that you're going to do that is by saying that every 15 degree change in longitude is going to equal approximately 1 hour in general. And in this case, in the first case, it's true, right? So we go from 120 degrees west to 90 degrees west. That would be a difference of 30 degrees. So when it's 7 p.m. in Fossil, Oregon, it's 2 hours later, or 9 p.m. in New Orleans, Louisiana. Sorry about that. And so the approximate difference in time, you would just take 2 hours there. And then you'll just plot the rest of these points on, always in the approximate difference in time. It's going to be difference from fossil origin. So essentially you're just counting the number of lines of longitude that you're going across, because each one of those is 15 minutes or 1 hour apart, and getting at your answer that way.